ladies and gentlemen. My name is Kevin Armstrong. I'm the Manufacturing Engineering Coordinator at Liburdi Automation. What I'm going to be presenting to you today is basically two products that were built in two totally different work cells. Now, these products share common parts, these products share common tools, common documentation for certain aspects, and common tools. We're going to show you how we took both of these products and created one universal work cell for both of them. To give you an idea of these two products, you can see them here. The first product is our Liburdi 240 and our P300. They're both welding power supplies. You can see the similarities and common parts here too. The chassis are pretty much the same, just a different color, so there's a lot of commonalities here. Inside of it, the cuts are a little bit different, so we're going to have some difficulties with this as well. So I'm going to go through our journey on how we took both these products and combined them and started producing them in one cell. So we'll talk about our objective. This is more or less our goals and initiatives in the end. We're going to talk about the CLE event as well. And this is the event that kind of really kick-started us in the right direction. Because at first we really didn't know where to start. So we're going to talk about some of the lead tools we use along the way. We're going to, of course, look at some before and some after. The results that come out of the okay. So this crazy diagram here is more or less our current state. So I will kind of explain this a little bit so you don't find all the red here. It's kind of confusing. But our objective in all this, we wanted to create one work cell and reduce space. So you can see the two work cells here, the P300 on the right, the Liburdi 240 on the left. We wanted to combine them both, and in the end, gain some more space, right? Self-explanatory. We wanted to reduce the control build times. So we actually wanted to reduce the build times because they were quite high. We'll show some results later. We also wanted to improve quality. We also wanted to reduce inventory kitting time and kitting errors because it was quite high as well. Give you a little bit of an explanation on this diagram. I'll kind of explain the flow, and I'll kind of explain how the cell works. I'll focus on how the cell works here. So we've got the Liburdi 240 cell here, as you can see. We've got four different sub-assembly stations. We've got one right here, we've got one up here, and we've got one over here, and then we've got the final assembly, which is done right here on the cart. So what we're doing is we've got a rack here, which stores parts to build that specific sub-assembly. And then the sub-assembly goes back on the rack. The same thing with here, and the same thing with here. And then when it comes to the final assembly, what we do is we pull all three sub-assemblies onto the cart, and then we produce the unit. That's kind of how we're doing it right now. Now, in the beginning, what we were doing is we were building batches of 10. So we weren't just building one unit here, we were building a batch of 10 units. So the units, the finished good units, we had a rack here, a rack here, a rack here, and a rack here. So that was kind of like our Kanban, let's say. We always wanted to keep 10 unit stock there for orders that come in. And they pull from that cart, go to test, and head out to the one. So we were building batches of 10. Now, when we release a work order, this is the batch of 10, all the material that comes in right here, as you can see. So the ladies upstairs in inventory, what they would do is they pull all the parts for all 10 units, dump them on one skid right here, in no particular order. And then it was up to the operator, or the assembler in the cell, to go through this mess of the skid, try and dig out all the parts that they need, and place them on the right corresponding racks, depending on what sub-assembly they belong to, and then the batch would begin. We set up for 4 people, so we have one on each station, one doing final assembly, then we go back to the 10, so there's 10 different sub-assemblies happening here. Exactly the same thing on the other side. I'm not going to repeat it, but it's exactly the same thing for this product. Same sub-assembly, same everything, was pretty much the same on that side. Now right up here, you can see there was one common toolbox. This toolbox was just stuff with just about every tool you could think of, no particular organization or anything. There was only one of them, so it was shared between both cells. So you could have a potential of 2 or 3 operators in each cell, all sharing one toolbox. And If you look at all the red lines, you can kind of see the flow here. It's kind of a mess here, as you can see. Parts come into the cell, they gotta go, they get stored in the rack. You got people building in workstations, they're dumping it on the rack. You got the guy from doing final assembly, he's pulling from all over the place, he's grabbing tools from over here. You can see it's chaotic right now. So that's kind of our current state. You can see if Tim Woods, Tim Woods was a person, I think you can see he's probably in all these different areas right now. First thing that we did was we had a CLE event. This is what really kicked us off. We weren't sure what direction to go and how to solve this. So we got Scott together. He brought 10 people to our facility. We went down to the floor and I showed them basically a current state. Kind of showed them what that map was in real time. We had people down there assembling. We had people down there putting things together, and we got to see what's really going on down there. After that, we went back upstairs. 2 groups were formed. And in the end, we needed 2 ideas on how to solve it. The first group, Group A, we come up with one option, which was more or less the simplest option. We were still going to produce a batch product, which was still 10 units. The sub-assemblies were still going to be built in 3 separate work areas, so there's no different. The max number of people would be 2 in this case. The kitted parts are stored next to each dedicated assembly station on a rack, which is no different than what it was before. The integration of final assembly is done on a cart. The finished goods are stored in the entrance of the cell. We're going to create some tool shadow boards to kind of clean up the tool bits. So that was option A. It was a simpler approach. Option B, on the other hand, we're going to go to what's called a single piece flow. This is something new for us we've never done before. We've always done batch production. That's the only thing we've ever known. So this idea was we took a look at it and decided to investigate it. Sub-assemblies were built on one table. One operator builds one product completely at the same time. Okay, so yeah, we got the sub-assemblies are built on a workbench. The final assembly is built on a cart. So you got one operator building the entire product completely on his own. 2 products can be built simultaneously in the same cell. So we have a max of 2 operators per cell. All kitted parts are stored in 1 of 2 incoming kit racks. But I'm going to show you what revision 2 was, because we actually stored all the parts in the actual cart itself. I'm going to show you how to do that. And the finished goods are stored in the entrance of the cell, just like it was, and then we're going to do some shadow boards connecting the tools. So we chose option B, so I'm going to focus on option B here. You can see option A here. We basically cut the cell in half. We kind of cut the same layout here. We had we basically cut it in half here. We had 1 sub-assembly here, 1 sub-assembly here, and 1 sub-assembly here, and then the final assembly done on the cart. 2 storage racks here for the finished goods, and it was basically the same flow. Now, if we go over here to option B, as you can see, it was a little bit different. This is again where we went to the single piece flow. So if you can see down here at the bottom, instead of a skid of 10 parts, or enough for 10 parts coming into the cell, it actually came in on a cart. So the cart was stocked with all the parts you need to build 1 unit. So we took that cart here, as you can see, up here in the middle of the cell. That was the first step. We had the chassis stored up here. We had 1 workbench, and then we had 1 rack here to store all the finished sub-assemblies. And then we had the 2 finished good racks here, as you can see. Now, we kept a quantity of 6 here. That's what we chose to do. Anytime an order comes in, we just pull from here. And that would be our Kanban to kind of signal us that we need to stock another unit there. So that's kind of how the flow of the new cell is going to go here. And the beauty of this is kind of how the cart structure works, and I'll explain that in a minute here. Some of the lean tools we used, we just looked at this one here, the spaghetti diagram. This was pretty useful for us to try and figure out how the cell was actually functioning, and when you put it in a format like this, you can see that there's a lot of waste happening. This is actually the new cell. This is actually the current state in a spaghetti diagram flow, as you can see. Here's the cart here that's stocked full of parts. And there's a second cart here. So what we can do is we can produce 2 units at the same time. So if you cut this cell in half here, you've got one workbench here where one operator can build all the sub-assemblies, store them on this rack. He can pull the chassis from here. And when he's done all the sub-assemblies, he builds the final assembly on the cart. You can do the exact same thing on this side over here. So you can simultaneously have 2 products being built at the same time. Some of the other lean tools we use, of course, we got rid of this tool cart, as you can see. And we went onto the right, you can see we made some nice shadow boards. So basically, we took all the tools that we actually need to produce both units. We've laid them out all nicely here on this tool board. We've got a bill of material here as well, so this calls out all the parts you actually need to build that unit. If you wanted to build the other unit, which is the P300, all you have to do is just take that and flip it over. You can see the bill of material for the other product there. So we really cleaned up all that. The other thing that we did too to improve productivity and quality is we went to standard work. So you can see here on the right hand side, this was some of the assembly documents that we were using before. Maybe some of you are familiar with this type of kind of IKEA assembly format, as you can see. There's lots of little red lines and notes here on here from me. The problem we had with this here was there's a lot of variation. If you give this drawing to 5 different people, you're going to get 5 different ways of putting it together, right? There's a lot of details that this could never cover in that drawing. So we went to this format here with some standard work. So I myself went out there and I started putting some of these units together myself, and brought my camera and my tablet, and I started to create some of these work documents. And the thing is, when you start doing that, you really realize that what these guys are actually doing out there, and some of the tools they're using, and some of the steps that they're using, you really find out a lot. You really, really do. Next here, this is of course the current state, or sorry, it used to be the current state of our whole system, so I kind of drew that out in a value stream map. You can see all the opportunities for improvement here, all the yellow bubbles. The before and after, well, before we talk about the before, I'm going to show you about this, this cart here. This is the cart that is actually storing all the parts for either unit. So you can see there's 5 trays, 1, 2, 3, 4, and 5. Now we mentioned before that I said that there was 4 different sub-assemblies, and then there's 1 tray up at the top here which actually holds all the tools. So all the tools that you need to build that final assembly. So each shelf here, if you pull it out, it's actually a shadow board. So if you look at the top one here, this is actually the back panel tray. If you pull that out, it's a shadow board. It shows you all the parts that you actually need to build that. There's actually a picture inside of it. There's the part number, there's the reference designator, and the quantity of actually how many you need. So it actually becomes quite visual now. When you actually pull that tray out, you can actually see if you actually have all the parts or if you don't. We get the right card here, so. And these ladies, the ladies in our inventory, they take this up to the top and kit this for us. It's actually so much easier. They just pull the tray out, they go on the rack, they drop all the parts in for us, and they know whether they actually have all the parts to put in there or not. And then it's going down to the cell, and then these guys are working right from this cart. You can also see in the top here, there's some locating holes. Yeah, that's where the finished unit sits on top. So before and after, of course, let's get to the results here. We've got the size. It used to be 750 square feet. We've reduced that down to 340 square feet, so that's well over 50% reduction. The number of staff we used to have was on average about 2 to 3. The number of staff we have now is 1 to 2. Most of the time it's just 1 because 1 is enough to keep up with our demand. The QC metrics, we were getting about 8 to 10 QC issues each unit. We dropped that down to 3 to 4 with the standard work procedures. The kitting time is about 1 to 2 days to kit a batch of 10 units. So you got to deal with a quantity of 10 of all the different parts. Now we're just dealing with 1 unit, so we can actually kit that whole cart in about 2 to 4 hours. The results with the Liburdi 240, it used to be 52 hours to build. We got that down to 33 hours. That's about 22% decrease. The P300 and the P300 before was 46 hours. We got that down to 32, which is about 20% reduction in build time too. Below my time.